I'm Igor. I'm a Python JavaScript developer. I'm making web applications for the last 14 years and make Python projects using these Python projects primarily for the last 10 years. So I have a lot of experience. Yeah, and the kind of agenda today we'll talk about my last to-date Python project that ran in production for 15 plus months. It's written on aiohttp. The project is for signing and sharing legal documents in Ukraine, so it's a real project that use real users, real business, and etc. And some process done in JavaScript because it needs to be done in browser rather than sending the data to backend. But all other necessary stuff done in Python with aiohttp. So let's start with the question: why to choose aiohttp and asyncio stack over Django and Flask? And the answer is pretty clear. Just to get to the hype train, and you will be very ready to be the real programmer because you're using asyncio right now. But if honest, aiohttp to be chosen when other frameworks fail. That's you need to remember every time. So this is a Django request response cycle, and it's pretty clear, and I believe most of you are familiar with it. So yeah, we have a client, we have a web server, our first proxy, and we have the second proxy that here is pretty small, but the Unicorn or USGI or another application server. And your web server proxy a lot of requests for you, and then VGI decided on which thread the request should be executed, etc., etc. And when you write in this small view layer, you don't care about the whole stuff. You just care about your view, about your models, about your database. And then you might run very quickly in some problems. So some general problems like serving big amount of concurrent users, what to do when you need to read a lot of concurrent requests with a lot of data, how to handle big amount of connections to data source, like for databases, for Redis, for other data sources like Elasticsearch, Kafka, Cassandra, etc., or how to make in big amounts of requests to external sources. So there's a lot of other problems, but they're like pretty general. This 3-1. So solving problems is also possible. It's not like we cannot solve these problems. We can add another instance with our application. It's pretty easy. Yeah, like we have 2 Django backends right now. We're adding another one. Like we are a rich one, so we have VC funding and we can do anything. Yeah, we can do some other, like adding some magic to our code, like adding eventlet or gevent that patch network libraries, and you will start using better concurrency because you will have ability to process more requests right now. Start looking to another solutions. You can like switch to Golang, whereas concurrency is done well, better in Python. Yeah, but what if your problem is not only your problem? What about Python developers also think about the problem? Python developers also understand that concurrent programming in Python is not ideal, and there are possible solutions to that problem. So they want to bring better concurrency to the Python, and in 3.4, I think that merged to the Python standard library. That was, I believe, 3-4 years ago. That was a lot of time ago. Yeah, and asyncio started using primarily for web development. That's because the asyncio author, Andrei Svetlov, is primarily a web developer from Kyiv, and he wanted to solve his own tasks with this new concurrency framework. So that's it. So import asyncio. Let's see what we have after importing asyncio, and honestly we don't have much. We just have infrastructure for writing concurrent code. We don't have anything that shine like Django or like Flask, so just after importing asyncio we're just able to run some concurrent code in event loop, and that's it. Like we have asyncio, event loop, coroutines, and tasks. not much to switch from Django or Flask. And that's the example of how running asyncio in Python 3.7. We have new function asyncio.run. But again, that's not much for erasing the previous sync flow. So again, asyncio is just an infrastructure. Asyncio itself not suitable for web development, and you need to have a web framework built on top of it. You need to have a way to communicate with your data sources, with your data storages, and you need a way to communicate with some external APIs. And that's how IO-libs founded, how IO-libs born. So first of all, there was aiohttp. aiohttp is a pretty interesting solution because it's itself a solution for two problems. First of all, for aiohttp contains a web framework. So we have aiohttp.web that handles requests from our users and understands that some route need to be wrote, some view need to be executed, etc., etc. And in the same time, aiohttp client, this library for communicating with external sources, like to making requests with, like in sync mode we do with Python request library. We right now using aiohttp client for do concurrent requests for external APIs. And on top of that, there are a lot of other IO-libs exist right now, like IOPG to communicate with PostgreSQL, asyncpg is faster way to communicate with PostgreSQL, IO-Redis, IO-AS, IO-Memcache, etc., etc., etc. So IO-libs. And that's it. That's how asyncio stack was born and start using in common language. So we in asyncio stack have concurrent code. So we have concurrent view execution due to nature of aiohttp web. We have concurrent communication with data sources due to nature of IOPG, asyncpg that run in async mode to communicate with PostgreSQL. And we have a concurrent way of fetching data from external API. On top of that, we right now don't need actually to use an application server with G to deploy our code to production. So, and we have a lot of async arrays all around our code. This is why we should choose aiohttp. So we want to figure out how we can use a lot as smallest amount of resources we have. We expect a lot of concurrent requests with a lot of request data from our users that need to be responded very, very quickly, and we have a lot of data to receive, like uploaded documents. Like a lot of users upload their documents to our service, and that documents maybe like 5 megabytes. It's not that much, but we have a lot of those requests, and we need a very quick way to communicate inside of our concurrent code with external APIs. Yeah, so I will have a very brief description of how a web framework using. So aiohttp web is not rocket science. It's pretty close to what we have in Django or Flask. You see, we have like this looks exactly like a Flask application with two differences. Yeah, first difference is we don't use decorator, but we already can use it in 3.3 for decorate our road. And second one, we have the coroutine to be executed instead of the normal Python def function. So it's not rocket science. And we don't need to deploy with application server. As of our aiohttp web already have a concurrent execution with inside of event loop. All we need to create an event loop, UV loop as performant one, and create the application and starts up. So that's it. So we don't need to care about Unicorn, waitress, etc., etc. We just awk with Python -m our app. Yeah, but The big difference between aiohttp and Django is that battery is not included, and that's very good point to remember. The battery is not included, so you need to instantiate your connection with database. You need to connect to your data sources by yourself. Very similar approach like in Flask, but a completely different approach like in Django. So yeah. Here is an example on how make the connection to database with IOPG library. So we create an engine by a signal. So on startup, we create a connection to database, and on shutdown of our application, we disconnect from database. Yeah, but the views are the same old views. The conception of views completely not changed. So as we have the view as main point of our applications in Django or Flask, we completely have this completely the same concept in aiohttp. So what we here is not production-ready code, but what we have here, we're uploading some documents. So yeah, we're reading from requests concurrently. It means that we are switching contexts, and if we have a lot of users, they not block each other. Then we upload some files to S3, then we insert some documents to database. Again, this is not production ready, and in production it looks a bit different, but the main thing is that the views not changed much. REST API, okay, so REST API, in our case, we done it manually. Maybe because we cannot to find good solution. Like in Django, we have amazing Django REST framework. I really love how guys manage it. And maybe this a new project from author of Django web framework will be good as well. But for our case, we do everything by ourselves. We validating transform the request data with Trafford library, we processing the saved data and return JSON responses. For public APIs, we're using Swagger, but only for docs. So that's, we do everything by ourselves. So no boilerplate code, everything like, not Ctrl-C, Ctrl-V, but very close to that. GraphQL, yeah, we also have support of GraphQL, and also we're using GraphQL to production. In our case, we're using internal library named Hiku, and it's not a good one. It's only read-only for fetching data, and that library mutations not present, as well as many other neat features. But there is a way to use that features with GraphQL aiohttp library that build on top of GraphQL core and run your selectors, run your resolvers inside of event loop, inside of aiohttp, I think event loop. Other parts of code, we also have a lot of different parts of code, but that's like two main parts of our code. So we have a big REST API, and we have GraphQL for reading data. And we also have task queue, internal API communicated with other products inside of holding, and et cetera, et cetera. So, did we really need aiohttp? And that's a good question that we need to continue to repeat questioning ourselves. So developers right now are very lazy. They wanted that one framework covered all the cases, but that's not how it works. That's not how it works, because the tool, the library, in most cases, they developed for one particular case. Like in aiohttp case, Andrei Svetlov, he works for his employer, and he wants to use asyncio, and he created the aiohttp, and he started using aiohttp for his particular case. And in that case, the aiohttp is good. And similar like for Django. Django was created like newspaper management system. And for newspapers, Django is great, but for some other products, Django is not that great. Don't forget about this. And don't forget that battery is not included. Like no Django admin. Yeah, we have the like aiohttp admin, but this is a like completely similar story like with Django admin and Flask admin. Yeah, we can use Flask admin, but why? Yeah, and no Django REST framework and no ORM. And like, why we need ORM? This is a beauty. This is like how we communicate with database on a regular basis. Like, why we need ORM? It's great. Yeah, but in reality, we just need to evaluate before implement. We didn't need admin for managing data because we don't want to admin our users' data. We're fine with that. We're fine with querying data without ORM because we think that this is a beauty. And we're fine with omitting some REST API framework and using and start doing our own mistakes. And we choose aiohttp here, especially because of concurrency, and let's see how it paid off. So real-life lessons from running aiohttp in production. Again, the application first public release was in January of 2017, so right now it have a lot of things we learned. First of all, aiohttp as Flask doesn't push your application structure, and that's bad. That's bad because it's very good when you have one developer per project and you're only one maintainer for your project. But when you have like a team with 3-4 people, it's very, very hard to maintain a vision of 3-4 developers on how things need to be done. So you need to enforce not only coding styles for your team, but you need to enforce like on how your application will be structured. How it will look like. In our case, it's looking something like that. So we have an application, we have a lot of sub-applications with DB is a layer for querying the database, enums. Yeah, we have a lot of enums. We have tables, that's SQL Alchemy core definition for tables. Types is for typing. Utils is some utils that's not related to database. And views and validators is pretty obvious. Views for the view layer and validators for validating data. And some other stuff like app, config, rows, signals, and etc. The setting is the same problem. You need to choose your own way of managing settings. Like in Django, we have settings.py. Here we're free to do anything. In our case, we're free to do, we choose to do storing settings in .yaml files and provide the traffic schema for validating these settings. And that means that if your settings not match your schema, your application will not start. Pretty clever. Accept everything. Yeah, that's the point with aiohttp. You need to expect everything. aiohttp is quite a young project. There is no knowledge base that's around Django, Flask. You need to expect everything. Like 2 times our code broken just after minor update or some like patch updates. Yeah, and it's like, why? Because it's nature of open source and adding some new features or fixing some old bugs by introducing new ones. And we're still using old UV loop version due to inability to upgrade because in our containers, new one UV loop doesn't work for us. Yeah, you need to expect that. And tests are necessary. In our case, in case of aiohttp, you cannot omit the tests. You just cannot. First our deploys was like with 5% of test coverage, and every time you just working in the morning and just first you go to the Kibana and it's like, oh, how much new errors the new deploy introduced, and the amount was a lot. And you need, with aiohttp, you need as well test routine things, like you don't need to test in Django because of that community, because of that knowledge base. You still need to do that. And that's a good point that typing will actually might help you. These type annotations are pretty useful for us. And instead of dict, we start using some more generalized, some more specified structures like name tuples, data classes added to Python 3.7 or even structured dicts. We start using more specified code because we understand that this function will return that, etc., and that the check every time. And that's also like documentations, and teammates very happy with idea all that code completion. What to do if we have CPU-bound code? So yeah, again, remember that if we need to process the XML from clients, It blocks our event loop, and that means that only one user will processing the XML, and all other users will wait before the processing done. So we need to use the running and executor, and here is a very simple example how zipping buffers with executor, but the way just you make your sync functions async functions. So yeah. And then you still need to remember that the aiohttp is still in development. So new features coming. New features coming. Like I said, like road decorator, and that means that can cost you, because like you start implementing the thing one way, and after authors of aiohttp so okay, that's wrong. We need to change it. And IOLibs maybe not cover everything you need. Maybe you sometimes need to make the driver for your specific data source. The good one, that web application is a great context holder. We learned that's a very, very easy way, because this is just a dict, and we can just instantiate that dict and then pass it everywhere on our app. We don't need to use our app only inside of web context. We can use it in web server context, in task queue context, everywhere we want. But then again, the question, where to find aiohttp devs? Like, what to do when we need to substitute? The few devs that like, okay, I'm done with that project, I want to do the new job. The market offers much less aiohttp devs with Django, with Flask ones. So maybe you need to grow the new one. And how to grow them? In case of aiohttp, you need to grow them with basic things, with understanding of the developer how the asyncio stack works in details. It might took longer that mentoring new developers in Django or Flask projects, and continue with basics like read, discuss aiohttp code. Yeah, aiohttp is not rocket science, but you need to invest a lot of time in that, and maybe it paid dividends later, but who knows. And I have much more lessons, but here a shorter one. So logs are very important. You need to log everything in aiohttp way. You need to have asyncio or Kibana or anything. You need to read the logs. You need to log your logs. You need to every day start from reading your logs and to see how much new warnings generated. Metrics are more important. You need to see if new deploy, not to introduce new memory leak, if everything works as well. The aiohttp is not that ready to use in production. It's ready to use in production, but you need to be ensure to use it in production. So metrics are important as well. And yeah, your dev environment in the aiohttp way, you need to be as much as closer to production. That's true for most environments, but in the aiohttp way, yeah, you just want to have ability to run your production code on your machine. Yeah, and don't forget about profiling your app, because profiling your app in aiohttp is pretty easy. Yeah, you just enabling the profiler, you just finally you just dump the stats from your profiler, and then using cache grind or any other tool, seeing what's going on with your application. And in case you need you debug your applications, please use IO Monitor. It's a pretty great tool to check which tasks are running, which tasks are good, which tasks are not used, which tasks can be cancelled, etc., etc. So yeah, you can debug, and you should debug in most cases. What's next for asyncio? Actually, I don't know, not much, because like in new features for asyncio, just more performance improvements. It's not like new things like async await statements, etc., etc. So that introduced recently. So just more performance improvements, but there are new competitors to aiohttp. There are new two libraries. One Courier, second one is Trio. That also done this async.io stuff, and maybe sometimes someone implement CoreHTTP, TrueHTTP, and other libraries. So does Python became better after async.io? I believe yes. Was aiohttp choice worth it for us? Yes. Did I repeat the right? I'm not sure. actually, I'm not sure, because I think your stack is harder. It's natural. It's new one, and it's harder one. You need to have more time for programming. Still new technology. Still less developers involved. Still less places to get feedback with, and most challenges ahead of you. But after all, I think your stack is ready. Choose wisely, expect everything, and with more challenges, anyway, you will become a better developer. So let's join the ride. Thanks.
Okay, thank you for the talk, and let's get to the Q&A. So, what advantages does aiohttp have over Tornado?
I believe the easiest one is that you don't need to use Tornado. But in reality, Tornado may be good for you. You need just to understand your needs, and if Tornado is good, you don't need to switch to your aiohttp or any other solution. aiohttp is good because it's already built on top of Python 3.6, so you're using the latest Python in production. You can use it with Tornado, with aiohttp loop. So not much advantages. Completely the same thing for concurrent code.
Good, thank you. Do you consider safe running aiohttp in production without application server as one process? What happens when a process crashes?
Sorry. When aiohttp process crashes, it starts a new one. Actually, no. Nothing has changed. Like in your Unicorn, when Unicorn crashes, it starts new Unicorn.
Good enough. Do you have any experience with Django channels, which is built on top of asyncio? Could you compare performance?
Yeah, I'm pretty interested with that project. I just read the slides from Andrew Godwin. I don't have an experience with it, and I hope that in a very short time it became a competitors, so we can start using that for production. Right now, I cannot compare the performance scalability because I cannot understand how to scale the Django channels with Daphne and all that stack. So I cannot answer that question.
Fair enough. Do you use WebSockets? And
yeah, for sure. Yeah, we're using WebSockets. They supported by aiohttp, and like if we have the talk like 2 years ago, that was my first slide. Like, see, the aiohttp supported WebSockets, and that's great. But right now it's just mainstream. Yeah, they use it. They just work out of the box.
Awesome. Why do you use both GraphQL and REST API? Could you use just one of them?
Why we use? So in every company, it starts from CTO. You know, the great technical decision starts with CTO. And CTO said, yeah, you need to use GraphQL because our company not that competitive on the market. And we start using GraphQL. In reality, we're using REST API and GraphQL only because we have an uploads. If we don't have an uploads, we will use GraphQL for everything. And for uploads, we can upload files with GraphQL by base64 them, but in that case we don't have stream uploads, etc., so we're a bit limited in our project.
Awesome. Have you encountered poison event loop? How do you monitor HTTP?
Yes, this IO monitor, but I didn't encounter some big problems in production, especially when I have some problems at my development environment. I using IO monitor to see what happens, but on production it's not that easy. So we didn't ever try it. Because we need to log into our container. In that container, just to have an access to pods that's only available in that container, and the container only run in saved environments that only have access by some people in the company. So that's very hard to debug, in our case, aiohttp on production.
Awesome. How do you deal with cancelled errors?
I ignore them. We have in Kibana, we have like warnings, the level error, and ignore cancelled error. I asked Andrei Svetlov a lot of times about cancelled errors, and every time he said like, okay, you can ignore them. Okay, I ignore them.
Okay. The next question. I suppose you choose asyncio for performance. How can you quantify the amount of resources
So
saved?
we're running like about 10K per second for our 3 instances. I believe that's okay. I'm not sure. We like in holding where I worked, main application built on top of pylons with big ancient code, etc., and it runs around 100 to 200 requests per second for 28, 30 instances with scaling down, etc. So I believe for us it's okay. If I start using Django, I believe Django will be okay for reading, but for uploading, I expect some problems with uploading many files concurrently in Django.
Okay, thank you.